Manoj sir, shall we start?
We can start.
Audible, sir. Shall we start?
Yes, sir. We can start. Good evening, participants. I'm very happy to invite you all for the 6-day online faculty development program on machine learning applications in mechanical engineering, trends and insights. Now, I would like to invite Dr. C. Prabha, Head of the Department Mechanical Engineering. We can start. Good evening, participants. To deliver the welcome address.
Thank you, Professor Manoj.
Online faculty development program on machine learning applications in mechanical engineering.
Respected Secretary, sir, Dr. R. Suresh Kumar, sir, our beloved Principal, Dr. N. Janahi Manohar, sir, distinguished resource person, Dr. M. Maheshwaran, sir, Professor, Department of Mechatronics Engineering, Nehru Institute of Engineering and Technology, Coimbatore, dear faculty participants and the organizing team, Professor Prakash and Professor Manoj Kumar. A very warm welcome to the 6-day faculty development program on machine learning applications in mechanical engineering, trends and insights. Today, mechanical engineering is evolving with data-driven intelligence. Machine learning is powering predictive maintenance, smart manufacturing, generative design, robotics, and digital twins, transforming how we design, build, and maintain systems. This FDP aims to equip faculty with current trends, practicals too, and research insights in machine learning so that we can nurture future ready engineers in our classrooms and labs. I express my sincere gratitude to our secretary, the management, and the principal and the faculty members of Mechanical Engineering Department of ACT for their constant support and vision. I also thank the head of Mechatronics Department, NIET, and the management of NIET for providing us with a resource person. I thank our resource person for accepting our invitation and the organizing team for their dedicated support in making this program possible. With great pleasure, I declare the FTP inaugurated. I welcome you all and wish everyone 6 days of productive learning and collaboration. Thank you. Now I request Professor Manoj Kumar to introduce the chief guest.
Thank you,
Sir,
ma'am.
please introduce the resource person, sir.
Yes, ma'am. It's my honor to introduce today's resource person, Dr. M. Maheshwaran, sir. He did his UG from Government College of Technology, Coimbatore, and Masters from VIT Vellore, and completed his PhD from Sastra University, Tanjavur. He worked in various reputed institutions like Milam Engineering College, Sastra University, and Addis Ababa Science and Technology University, Ethiopia. Currently, he is working as a professor in Nehru Institute of Engineering and Technology, Coimbatore. Sir published around 20 research papers and 5 patents and 5 books also. He is specialized in the field of mechatronics, robotics, and industrial automation. Thank you, sir. We welcome, sir. Now the session is yours, sir. Please over to you, sir.
Thank you, sir. Thank you, sir. Good evening, everyone. First, I thank Arjun College of Technology Management and Principal, sir, and Dr. C. Prabha, HOD Mechanical, for providing me the opportunity to present a session on this auspicious occasion. Thank you all. First, I planned to frame this topic, machine learning applications in the mechanical engineering trends and insights, for the faculty members, those who are planning to start the PhD in the area of ML, AI, and deep learning related to mechanical applications. So, specifically for the beginners of the in the research milestone, I planned for them specifically. And those who are at the end of the research, this session may be insightful to some extent, mainly for beginners of their career research in this area mainly. First, we will start from a basic introduction. As ma'am described the features of the ML in the integration with the mechanical engineering with the salient features she mentioned, and then digital twins, and then digital transformation, and so many. This application for manufacturing, maintenance, and automation, as ma'am told them, and the types of machine learning, we can generally classify into supervised learning, unsupervised learning, and then semi-supervised learning, reinforcement learning. Mainly, we are going to focus supervised learning with classification. And the first one, supervised learning, further classified into regression and classification, the third step, and then medical imaging. Medical imaging for mechanical field, we can convert this medical imaging into predictive maintenance. Later on, we will see as a case study. Here, the machine learning toolboxes. First, physically, we are obtaining the signals in terms of data acquisition and then data processing. As ma'am told, data driven. Mainly, it's a data driven. And then fitting the machine learning models, and then validation, finally in the prediction of the model. We will discuss this layout in various slides in our presentation. So the data acquisition from physical equipment, such as sensors, like sometimes it may be simulated environment. So real-time environment and simulated environment, we can give a data. So mainly it is a data. So large size data and small size data, these are the deciding factors of selecting the models, learning models. For example, if you are using ANN, what is the criteria for selecting the ANN? If you are using the SVM, what is the criteria for that? So some fundamental things should be covered so that we can go through without any hurdle. And the data processing here, further it covers data cleaning, data transforming, data reduction. So using Python, these mathematical operations on the data can be carried out. And then fitting the machine learning models. Fitting here further classified into underfitting and overfitting. So which one is error prone, more error prone? So that should be reduced. The SVM means support vector machine, which is not using large number of data. So learning method is different from ANN. So all are not using the input node, hidden nodes, and then hidden layer. Various number of hidden layers, hidden layer 1, hidden layer 2, hidden layer 3, and finally we can have the output node. So if you are using more number of hidden layers, that coming under deep learning. If you are using minimal number of hidden layers, it is normal ML. So ANN back propagation, using the back propagation, and then CNN, so many fitting models are there, that learning models. So fitting here means whether the model is having error or close to the defined or set value like. So validation here R square, the statistical aspects RMSE, all are related to error. All are related to error. So the E for error, root mean square, RMS root mean square. Here mean absolute, that deviation, mean absolute deviation in the error. A for absolute, and then P for percentage, mean absolute percentage error. The last one MSE, so mean square error. So these are the important statistical parameters that are governing the error predictions. So using the numerical values and then some graphical visualization, we are validating the model by using these statistical parameters. Finally, what is the deviation between your goal and the predicted value? That error should be minimized. That is a goal. And then here, the another version, how ML is classified for various applications. The first one already we supervised learning and then classification. So this is the thing we are going to discuss. The first one, discrete and qualitative. For example, failure. Bearing failure. Shaft is mounted over the bearings that may be fitted with further rotating elements, gears, and then other rotating masses. So these are highly sensitive, depends upon the applications. Heavy machineries, costlier one. So predictive maintenance is very critical. That should be accompanied with a particular setup. Setup means necessary sensors and data acquisition systems, and then model. That model of predicting the error. Finally, we are classifying the particular vibration signature is healthy or not. Here, machine learning, further we are reinforcing our idea, basic idea, what is supervised learning, which is the thing we are going to discuss in deep, not others. So there is a line which is classifying two set of data, A and B, like one may be faulty, another may be healthy in case of bearing failure detection analysis. And then these are the types of models which we can use in the ML. Mainly we are dealing with a support vector machine and then ANN related. These two we are comparing and we are understanding how it works. So mainly we are going to discuss about the support vector machine. This one. The machine learning and deep learning, how it differs. So more number of hidden layers, if it is placed, that's one reason when you can call it as a deep learning. And then it is a subset of artificial intelligence. And then it uses data-driven models. And then why ML is in mechanical engineering? Sorry for the interruption. Large volumes of the sensor and operational data. It's an automation and optimization of a particular parameter what we need to and then reducing the human intervention, enhancing the efficiency, accuracy, supporting the industry 4.0 initiatives. These are the features supporting points for how ML is connected to the ML mechanical engineering. Key areas of the applications: predictive maintenance, smart manufacturing, quality control, robotics automation, thermal and fluid systems, structural health monitoring. So, health monitoring of the civil structures in terms of bridges coming under this, using the sensors and data acquisition systems by getting the vibration signals, dynamic situations. And then predictive maintenance using the sensor data. Here we can see the regression models, classification models are there. Now we are focusing the classification models, but why we are selecting this particular model? There is a justification. So these are the basic concepts, selection criteria. Based on that, we are selecting the models, accuracy record, and then data volume, size. These are the things. Benefits are given: reduced downtime, cost saving, increased reliability, and then smart manufacturing, integration with the CNC machine systems with IoT system, and then it optimizes the production scheduling, energy consumption, and then process parameters. Quality control, these are the things. ML based vision systems inspect the product, computer vision, machine vision, robotic vision, everything is same only. So based on the image, it processes the need, what to be determined. It detects the defects using the image processing. For example, if the fruits and the conveyor, which one is rotten, that can be detected and it can be informed, or it can be diverted from the main conveyor. Reduces the manual inspection errors, surface crack detection in the materials, non-destructive testing like. And then thermal fluid systems, it is not main discussion for us. This is, we can skip. Here we are mainly going to discuss the support vector machines. Other algorithms here: linear regression, decision trees, ANN, and K means clustering. These are the few algorithms in ML. Support vector machine we are going to discuss later. And then tools and technologies. So Python and MATLAB. Here libraries. This will be useful information for the beginners, those who are in the idea of selecting this area. TensorFlow, ACI, Kitlearn, PyTorch, and then hardware sensors, IoT devices, embedded systems. Embedded systems, mainly the dedicated application for a particular controller is called embedded system. Integration with the mechanical system, ML, along with the IoT, which is called smart systems, cipher physical systems, and then digital twins for other aspects. Case study here: predictive maintenance of the bearings. What's the input we are giving? Vibration signatures or vibration data, or any other real time that vibration signal, time varying signals. Model, it may be neural network or SVM, support vector machine. Here in this slide, it is given neural network. The output may be whether it is healthier or which type of failure. Failure is a common term, but in case of bearing, it may be outer race or inner race or ball gauge, ball. All aspects we can specifically we can get the data from the model. Which one is healthier, which one is not healthier. Results: increased machine lifespan, since it is predicted earlier, the necessary action is taken that would lead to longer life of the particular setup. reduced maintenance cost since breakdown is avoided. Vibration signature analysis, for example, here, the technique for the machine fault identification, which is based on the principle that all the system produces a vibration. So this is a fundamental aspects. Similarly, all the systems may emit some radiations. Biological living things may emit some infrared signals from our body that could be detected, even though if it is very small in the magnitude, that could be detected by camera, thermal imaging camera like. So change in the, similarly, all the rotating parts, mechanical systems rotating, so that will produce vibration. That is the essence of this analysis. Primary source of the signal generation is from the vibration. So normal vibration is compared with abnormal. Is there is an anomaly. Anomaly means this there is a deviation from the normal running. Due to various reasons, it may give the signal that is getting affected, or it is running radial offsets, like change in the vibration spectrum of the machine due to fault. So they are checking with the standard signals, vibration, how it is producing a peak within the short time. So that time window is represented with high peak in amplitude. That is giving a signal of something is not normal. So this is a basic idea of using the vibration as a source for identifying the faults. So bearing here, it's accelerometers are the sensors which are mounted. Here one more sensor is mounted on the bearing 4, which is thermocouple. So it's a temperature sensor, not necessarily thermocouple. We can mount many other types of temperature sensors. Thermocouples, piles, and positive temperature coefficient, beads like structures. Many types are there. RTD, which is giving electrical signals, that could be used for identifying the faulty conditions, since if anything heat is produced abnormally, that also a source for identifying faults. So due to friction, due to misalignments, due to slip, so many reasons are there. So if the temperature is increasing the set level, that is the indication something is not normal. So accelerometer, simply a vibro structure like cantilever beam. It is having the proof mass at the end of the cantilever, small size cantilever. It is totally encapsulated with a viscous medium. The cantilever is having some wheatstone bridge on its circuit, on its plane. If any jerk accelerometer is facing, that strain gauges implanted on the surface of the cantilever beam of the accelerometer, the resistance variation that gives a change in the current flow through the circuits, that could be suitably calibrated, so that the unknown parameter or extra, that changing parameter, disturbing parameter could be sensed by using the accelerometer. So motor pulley arrangements, this one, it is fitted with the radial loads. So this is a normal scenario. We are discussing the ML applications in the predictive maintenance of the bearing failure. Some another basic information related to Python libraries for the machine learning. So NUMPY. So this is normally available, popularly available for machine learning through Python. So number NUM for number or numerical. Numerical PY, Python. Pandas for data manipulation. These two, you just remember the names. When it comes, we can install and you can use the libraries. So simulated environment, we can use the data sets and uploading the data sets, and we can get the output, training sets, using the training sets and then testing sets. Finally, you can predict something. That data is already available. You are downloading and you are utilizing the data, not from the real-time data. It's already available data in the web. So Pandas is that particular mathematical tool for data manipulations in terms of matrix, arrays and rows, like transpose of the matrix, inverse of the matrix, like normally we are doing in other programming languages. Here they are using the Pandas for specifically for doing the processing of large number of data, large size of the data. Here we can understand one thing. If the signal is coming inside, the signal is not stored as a signal, it is stored as a data. So that is the point. Numerical Python fundamentals. What are the functions it can do? Array manipulations. It can do mathematical functions. It can do linear algebra. It can do the random number generation. These are the four tasks or functions the numerical Python can do by following some fundamentals and syntaxes and the given structures. You can learn the basics so that you can understand these one. These are things available related to Python that can be used for simulating the data in the ML. So that is the point you would understand. So Python, numerical Python. So this basic idea, I think it is enough. We can slightly skip. We can read one more line. It provides a high performance multi-dimensional array object and tools for working with these arrays. It is a fundamental package for scientific computing with Python. So it's a inbuilt with Python, so that you can utilize this for manipulating or doing the mathematical operations on the large size of the data. That's the main point. You have to keep it in your mind. For example, we can do a simple data, how it works. Import pandas as PD. PD here means panda. Short name of pandas is called PD. Here we are defining data, name, and then age. In the under the category of the name, player A, player B, player C. We can give any names also, but here A, B, C players are given. Their age values are numerical values also given. Here data frame, DF means data frame. How the data frame is very important. Here the panda PD dot data frame data print DF, how it works. So this small piece of algorithm, if it is written in this way, how it gives the output, we will see the output. So this is the output, name, player A, player B, player C in a particular second column, or it may be taken as a first column. This is serial number. First column, player names. Second column, and then age. So discrete data is given or presented in terms of a data frame. So this is a thing you have to understand how it could be programmed for a particular small information. So 3 persons, their 3 data, how the data frame, if it is programmed, then the printout will give you the particular style of display. Series in Panda. Similarly, you can understand the remaining thing. Similarly, you can understand the remaining thing. We will skip. So understanding and analyzing the data frame, since it is data driven. So as ma'am told, it's a data driven data intensive. So we have to understand the process before entering into the full-fledged ML usage or practice. So these are the background knowledge you need. So again, the name, age, city, if it is given, what will be the output? This will be the output. So in this way, according to your applications, you can manipulate or you can utilize the particular module in the Python. Understanding the analyzing the data frame, it's also very important. Why it is important means data cleansing. Data cleansing or cleaning is also very important. Spurious data, anything that is not consistent with the data, that should be removed. So that is called data cleaning. Any abnormal value that is given as a input means that will give you the wrong predictions. So before wrong predictions, we are segregating or we are expelling the data which is not suitable to the particular applications. Erroneous data, that may be erroneous data, abnormal data, that should be removed. So how it could be identified or detected and how it could be selectively removed. So these are the next level of understanding. So understanding the analyzing the data frame, the basic statistical details, data types, non-null counts, and then check for missing data, inspect the data frame shape, rows and columns, mainly for the matrix like tabular column like or matrix like data structures. Checking the rows with the minimum and maximum values. These two are to be carefully observed, the minimum and maximum values. Indexing in the pandas. So understanding the pandas and then given sequence, this is the sixth point. Indexing in panda refers to the process of accessing and selecting the data from pandas, data frame or series. Panda is having two classifications under data and series. There are multiple ways to do this. This is separate topic. If anyone is interested, we can go through and read more on this. Import pandas as PD, row by label, row by position. These two are the features we can do the programming more efficiently. If you are thorough with this, having understanding with this programming, you can do the data process efficiently. That's the point. Row by label. Label means calling by name. And row by position, we can do the same operations, whatever you like. Selecting and filtering the data based on conditions. Just keep it the title itself, it is enough. Selecting and filtering data based on conditions. Okay, this is one point we have to keep it in our mind in ML processing. And then some condition based data preparation for machine learning. So since it is data intensive, we have to be very careful with the data preparation for machine learning. Based on the data quality, purity, the prediction is accordingly. So the data preparation is a critical step. The raw data is cleaned and transformed to make it suitable for model training. So before training the model, we have to be very careful with the data sets and its purity. Loading the data sets using the pandas. So you cannot avoid these kind of terminologies while you are proceeding with the your applications in your research or any other projects or any other paper publication works. These are the inevitable terminologies coming across. Pandas, loading the data sets using the pandas, understanding the data set structures, data pre-processing, data cleansing, handling missing values, removing the duplicate records, features scaling using the standard scaler and min-max scaler, encoding the categorical data, train and test percentage data, split using SCI kit learn. Okay, so just you understand these are the things or steps we must be careful before giving the training to the model. So each and every line is a big topic. Like minimum you have to go through one page or 2 pages information regarding the each heading. So this is minimum level understanding. You have to go through all those things. Supervised learning is a labeled data. So it is called supervised learning. The data is labeled. And then regression algorithms, this is a basic, not very much going to be discussed later on. It's a very basic thing. Just these are the things available for regression algorithms related to ML. That's all. Here the support vector regression, support vector machine is different. Here SVM is going to be discussed later on in the presentation. And then here it is SVR. It is different. Classification algorithms. You see, this is regression algorithms. This is classification algorithms. In the earlier slides, we have already seen why it is regression, why it is classification, why these difference coming across in the machine learning process. Based on our need and applications, we are selecting the models and algorithms. So here classification, 2 sets of data for the bearing fault detections. One is for good conditions, another is for faulty conditions. So classification between these two only. Some algorithms are giving numerical values finally. That is different. So that is based on their own need and applications. Here, a classification algorithm is going to be used for identifying the fault in the bearings. It means it is a costlier, so that we are going for this kind of complex analysis. And then support vector machine is the model we are using. Other models are also given. Logistic regression. You see, the regression is a term coming under classification. Here you see a regression is a separate topic. But here the logistic regression is coming under classification. K nearest neighborhoods and naive Bayes algorithm, decision tree classifier, random forest classifier. So the random forest, the tree-based algorithms are mainly used in AI sets algorithms. AI sets algorithms, min-max problems, random for that structure like. This we can skip since we are not discussing about unsupervised learning, but it is there. We can understand. Okay, these are the things available for unsupervised learning. Why we have to go for unsupervised? There will be a justification for the selection of unsupervised learning. At the time, it is used there. That's all. Model evaluation and validation. Here, model evaluation very important. After learning, it should be tested that error is there or not, whether it is learning properly, learned properly, or it is not at all learning. Some statistical measures, parameters, we can identify the particular model is capable of predicting with particular level of accuracy, like that error level is very important. Otherwise, the prediction is now of no use. So underfitting, overfitting, and bias variance, these terms should be learned properly by the beginners. Each and every term, why it is, how it is, looks like in graphical sense and definition sense and formula aspects, you have to be known to these kind of parameters, so that it is another step in the ML learning. Machine learning, we are learning the machine learning. So these are the steps you have to go through. Just understand these terms, and when you find the time, you can go through one by one. So it's data frames and series connected to pandas. It's a high impact Python library designed for data manipulation and analysis. So understand the importance of the given tools. It streamlines the process of cleaning, transforming and analyzing the large data sets with the speed and precision. So precision here means it may not be accurate. So the accuracy is different, precision is different. So as you know, true value, how far precision may be away from the true value, but repeatedly it is shown, but it cannot be taken as a true value. Error, but the error is repeated in the same point. That is precision. Accuracy, exact true value, there should not be any deviation. That's accuracy. Here, seamlessly integrated with Python. Okay, we will move to the next one. Just I am underlining the important things. You can gather or you can keep it as a hint for further studies. Creating data frames. Just we can move to the another slide. The Python code fault versus healthy classification. This uses a support vector machine for classification. Now, we have already discussed classification algorithm under which the support vector machine is an algorithm. Coming under this category, classification category, support vector machine is a model algorithm using for predicting the healthy and faulty conditions. It looks like NUMPY means numerical Python. Just understand. So this may be the code may be representing for generating the data set. Generating the data set. So it looks like. So it is for simulating the faulty conditions or healthy conditions, creating the data sets. It looks like this kind of train the test, train, test, split. You see, training is one stage, testing is another stage. So we are using the source data for same source of data for these two processes. 80% or 70% it can be used for training. Remaining 20% or 30% may be used for testing. All are may not be real data. It may not be a real data. It is a simulated data. In order to understand the model, then we are training with the actual data, real-time data, how it works. So interfacing the model, computer model with real-world physical setups, interfacing. That is also to be a very good, interesting area to know or learn to understand. So understand these kind of terminologies while training the ML model, and then prediction, this step, it looks like in the algorithm, and then accuracy, and then test new signal. These are the algorithm for this step. Okay. This is the introduction part of my presentation. Now we are moving to another slide. My time is given 6:45. So with already 3 minutes over. So I am moving fast. With another 5 minutes, I will complete the case study slide. As a case study, the bearing fault detection using vibration signals, sometimes it may be termed as signatures. Why it is important? Early detection avoids the costly breakdowns. That's all, nothing else. Here, what is the input given to extracted features from the vibration signals? Finally, it is stored in terms of numbers only, data only, not as a signal itself. Here, the output bearing conditions healthy. The fault may be 3 types: inner, outer race, and ball defect. Ball gauge, that defect, gauge defect. Algorithms here we use for example as a case study SVM. support vector machine only. So the image shows that the bearing may be used for normal or costlier machineries. Anywhere it can be used, but it is for bearing the loads, rotating elements, shafts like. And then difference between the SVM and ANN, the basic, it is optimization. It finds a best fit line. The support vector machine, it predicts a line. Above the line, accepted, below the line, not accepted. So it statistically, it optimizes a line in a hyperplane. So that is a working methodology or style of the support vector machine. But ANN, it uses neurons, layered neurons, input layer, final output layer, in between hidden layers, where the weighted neurons that is triggering the outputs biased. So many fundamentals are there. That fundamentals we are not looking here. But there is a difference between SVM and ANN. Using the SVM, what are the parameters? You have to give the parameter as a RMS, root mean square, that related inputs, and then peak kurtosis, and then normal vibration, and then fault vibration. These two, it will create a boundary line. That is a statistically a boundary between the fault and healthy that parameters, that particular vibration data. Using ANN, the same features, raw signal, ANN learns complex non-linear patterns internal. This working learning mechanism is different from SVM learning mechanism. That's the point they are mentioning here. The hyperplane, the distance between the margin, these red color data, class A samples, the blue color squares. The blue color squares are class B sample. So one may be good, another may be fault, normal, fault. So distance between these two is given by some parameters, numerical parameters. Here the optimal hyperplane Wx plus B is equal to 0. Weight, W for weight. And then it is separating. You see these two lines are, margins are separated. This dashed line is margin for blue color data. This dashed line X1 is a boundary for the red dots. How these two margins are separated sufficiently, that's my point. It should not be too close. It should be reasonably far away from each other. So that is the expected from the SVM. Sometimes the SVM may be non-linear. So linear case already we discussed, non-linear case maybe in the right side one. And then how this data in the two-dimensional and how it is placed in the higher plane, which is having the three-dimensional features. So this is a fundamental where you can understand, SVM used for classification in this way. Okay. So fundamental understanding is very important rather than directly moving without basic understanding. If you are doing anything, that won't give you the complete satisfaction of the learning or the machine learning. So how SVM learns the boundary? So learning, how it learns. So that is a expression or definitions are given here. It's a mathematics and optimization. That's all. That is a learning through iterations. It finds a line or plane. That is a main objective of the SVM learning. That line is the prediction where other two sets can be classified. Classification. How ANN would do it? ANN learns it is differently. It uses the layers of the neurons, adjusting the weights through backpropagation network, BPN, and gradient descent error minimization. So learning mechanism in the SVM, I go first, minimizing the model complexity and then classification errors. It is done using the convex optimization techniques. So SVM solves an optimization problem. First you remember this point. Again, these are the things could be clearly predicted by the machine learning methods. By using this step, it is taken from this particular HTTPS guide of greece.com. And then motor setup, torque measurement shaft, bearing modules, flywheels, load motors. It's an experimental setup where we are obtaining or generating vibration signals in order to learn or giving the training to the particular model. It's not meant for any production line. It's only meant for training the models. So this physical setup is used for that. Here you see current transducer, frequency inverter, low pass filter, speed and torque measurements, and then surface acceleration. Temperature is also a matter. Low pass filters, analog to digital converters. Finally, data is getting stored. So A to D conversion, analog is the naturally occurring the signals where we are converting into digital, where the data could be stored in the digital memories. So after this, I will stop my presentation. If any questions, you please.
Dear participants, if you have any doubts, please unmute your mic and please ask your doubts with our resource person. Dear participants, now this is the time for discussion. If you have any doubts, please clarify with our resource person.
Ms. Neha Sharma, do you have any doubt? Hello? Madam, you are not audible. You can post your doubts in as a message also, madam.
Dear participants, if you have any internet connectivity problem like that, just message the query in the chat box itself.
Manoj sir, it's fine. Manoj sir, we can proceed.
Yes, ma'am. Okay. Sir, I think all the participants are okay with that. Now I invite Mr. V. Prakash to deliver the vote of thanks. Prakash, sir?
Thank you, Manoj, sir.
Yes, sir.
Good evening to all. It's my privilege to propose a vote of thanks at this wonderful evening. I express our deepest gratitude to our Honorable Chairman, Sri R. Suryanarayanan, sir, Managing Trustee Engineer G. Srinivasan, sir, Trustees Sri D. Raja, sir, and Secretary Dr. R. Suresh Kumar, sir, for their visionary leadership and constant encouragement. And for facilitating all the arrangement to ensure the smooth conduct of this FDP program. Our heartfelt thanks to our principal, Dr. N. Janahim Manohar, sir, for the motivation, timely approval, and for the presiding over this event. We are profoundly grateful to Dr. M. Mageshwaran sir, Professor, Mechatronics, Nehru Institute of Engineering and Technology, Coimbatore, for accepting our invitation and for enlightening the session. Your expertise on the today's topic has given us new insights and will surely benefit our faculty and researchers. I thank our head of the department, Dr. C. Prabha ma'am, for her meticulous planning, coordination, and for providing us this learning platform. Thank you, ma'am. My sincere appreciation to all faculty members, research scholars, and participants from various institutions. Your active involvement and thoughtful questions made the sessions interactive and meaningful. Finally, I thank all my department colleagues and the organizing team for their dedication and teamwork. Thank you. On behalf of organizing committee, I once again thank everyone who contributed making this event a grand success. We look forward to your continued support in future endeavors. Thank you. Thank you all.
Thank you, sir.
Thank you very much, sir.
Thank you,
Thank you,
ma'am.
ma'am. Thank you, ma'am.
Two participants have posted their feedback as it was
Yes,
a very
ma'am.
informative session, sir. Really, it was a very informative session. Thank you very much,
Okay,
sir.
okay. Thank you, ma'am.
Thank you, sir.
Thank you, ma'am.
Thank you,
You
sir.
can leave the call now, sir.
Yes, ma'am.
Yes, sir. Dear participants, thank you for your active participation. We see you tomorrow also. Thank you.
Dear participants, please kindly fill the feedback form for the today's session. I post the feedback form in the chat box. The feedback form is available in the chat box, so kindly fill it. Dear participants, the feedback form is available in the chat box. Kindly fill the feedback form for the today's session. Yes, sir, I'll share the feedback form, sir. Vignesh, sir? Got it, sir?